Okay, I've divided chapter 21 into 4 sections. So there are going to be 4 videos, and you can re-look at those that are challenging, look at those that come easily. So the 4 sections are the quality of the data, statistical significance versus practical importance, type 1 versus type 2 errors, and the Bonferroni adjustment. So first, the quality of the data. Really, that's the most important question. How good are the data? Because if there's a lot of bias, if our sample does not look like the population, then all bets are off. We can't do any statistical inference. We can't draw any conclusions about the population if our sample does not look like the population. So in this new handout, I talked about a few different polls comparing the results of volunteer samples to random samples. So first, when Bill Clinton was doing inappropriate things with Monica Lewinsky, there was a sample of 200,000 people. And of those, 73% thought Bill Clinton should leave office. But those were all volunteers. That MSNBC just posted a question on their website. Over 200,000 people chose to respond, and they overwhelmingly thought that Bill Clinton should leave office. At the same time, a simple random sample was done, and only 34% thought Bill Clinton should leave office. That had a margin of error of 2.2%. So 34% plus and minus 2.2%. So the true percent of Americans who thought that Bill Clinton should leave office is probably, so 34 plus or minus 2.2. So that gives us 31.8 to 36.2%. So the true percent of Americans who thought that Bill Clinton should leave office is probably somewhere in that range, but the volunteer sample claimed it was 73%. So it was about 40% off. And then more recently in 2016, after debates between Donald Trump and Hillary Clinton, Breitbart, Fox, and others put on online surveys after a debate between Donald Trump and Hillary Clinton, and people who responded to those surveys thought that Trump beat Clinton by about 70% to 30%. But again, they were volunteer samples, that the only people who were responding were people who were looking at Breitbart, were looking at Fox, and people could vote as often as they wanted. So people could just sit there and vote repeatedly for Donald Trump as that they thought he won the debate. In polls where people were chosen at random, well, then Clinton won by an average of 24%. So the volunteer samples were off by about 64%, from Trump up 40% to down 24%. So these are called non-sampling errors. We have sampling errors, the amount we're off a little bit because we have a sample instead of the whole population. And then we have these non-sampling errors, things like undercoverage and non-response and response bias and volunteer samples. Those we can't put a number on because we don't know the effect they're having in general. So we just have to acknowledge that our confidence interval is really optimistic because it only includes that one kind of error. We're off a little bit just by sheer bad luck because our sample doesn't look exactly like the population. It's all these other things that we have to minimize as best we can because they are not included in a confidence interval. So your biggest question with any study is always, are these good data? Are these good data?